In the dark between worlds, something older than our ocean slides across the plane of our solar system, a traveler from a distant sun, carrying the chemistry of a foreign sky. Astronomers call it 3I Atlas, the third confirmed interstellar object ever found, a small body on a hyperbolic path, never bound to our star and never to return. It arrived in our data before it arrived in our imagination, streaks on stacked images, a moving point among fixed stars, then unfolded into a coma, a faint breath of dust, and a long list of questions. How big is this thing? What is it made of? Why does its dust behave so strangely? And what can a single shard from another system tell us about how planets form everywhere? Adjust your eyes to the low light of deep time. Tune your ears to the whisper of spectroscopy. Tonight, we follow 3I Atlas across the inner realms, from discovery to perihelion, from speculation to measurement. Let us begin. The first act opens on July 1, 2025, at the Atlas Survey Station in Rio Atodo, Chile. The system's job is humble and heroic: scan the sky for anything that moves the wrong way, warn us if it aims for Earth, and log the rest for science. In a sequence of exposures, a faint mover separates itself from background stars. Orbit fits quickly flag something remarkable: a hyperbolic trajectory, eccentricity greater than 1, meaning the object is not gravitationally bound to the Sun. It does not orbit, it passes through. Within days, the designation settles, CO 2025 N1, Atlas, and with the interstellar nature confirmed, the short label 3I Atlas joins a small, historic club that previously admitted only 1I Oumuamua and 2I Borisov. The numbers are stark. The inbound speed is roughly 60 km per second, fast even by interstellar standards, placing 3I Atlas among the swiftest natural bodies we've clocked on such a path. Statisticians note the coincidence that its trajectory lies very near the ecliptic, the crowded plane where planets roam. Coincidence or clue, it puts 3I Atlas on a geometry that intersects the attention of every major observatory preparing to watch a comet that does not belong to us. Plot the track and you get a crisp arc bending sunward, then away, an open curve that never closes. The solutions agree: closest approach to the Sun will occur around October 29 to 30, 2025, at a distance of about 1.36 to 1 point for astronomical units, inside Mars's orbit but well outside Earth's. Our planet will never be closer than 1.8 AU, meaning 3I Atlas is a spectacle for telescopes, not a threat for headlines. After perihelion, it will accelerate back into the galactic night, its outbound leg written by the same physics that brought it here. Waypoints on this pilgrim's map mark near misses that are far in human terms but close in celestial ones, a pass by Mars of roughly 0. 19 Australian dollars in early October, a brush with Venus at 0.65 AU in early November, and a more distant wave to Jupiter in March 2026 as it exits. Each encounter offers a vantage point, an opportunity for orbiters and ground-based arrays to sharpen images, tease out composition, and watch how sunlight and vacuum sculpt its coma and tail. On July 21, 2025, Hubble settles its gaze and gives us the first high-confidence portrait, a teardrop of dust swelling from a compact nucleus, background stars drawn into streaks as the telescope tracks the moving target. From that dataset, astronomers set an upper limit on the nucleus, no larger than about 5.6 kilometers. At the small end, it could be as little as 320 meters across. That is a wide bracket, but a crucial one. An object measured in hundreds of meters behaves very differently, thermally and dynamically, than a multi-kilometer ice ball. The uncertainty becomes a plot line in its own right, one that will constrain models of outgassing, crust strength, and the amount of ancient ices available to sublimate as sunlight intensifies. If those numbers feel familiar, they should. 1I Oumuamua baffled us in 2017 partly because it was small, faint, and active in unorthodox ways. 2I the Borisov, by contrast, looked and behaved like a classic comet. 3I Atlas seems to straddle that spectrum, unmistakably Carmetarian imaging, yet with behaviors that, at times, defy tidy categorization. Then came a puzzler. Imaging and analysis suggested a dust morphology that, in some sequences, appeared to point sunward, as though grains were being lofted in a direction counterintuitive to the usual solar wind plus radiation pressure dance. The effect launched a flurry of modeling. Was this an interplay of grain size, release velocity, and viewing geometry? A transient jet? Or a sign of crust physics we haven't catalogued in our native comets? The headline version, tail pointing forward, is an oversimplification, but the underlying question is serious. What cocktail of forces and particle properties can reproduce the observed brightness contours? As more photometry arrives across filters, teams are refining grain-size distributions and emission cones to square model with sky. This is how science works at the edge of signal: a weird map, a tentative explanation, a better map, a refined explanation. That cycle is already shrinking as the comet brightens on approach, and as more instruments, polarimeters, spectrographs, and high-cadence imagers join the hunt. The romance of interstellar travel meets the rigor of celestial mechanics in a single statistic: speed. Inbound velocities around 60 to 61 km/s make 3I Atlas one of the fastest natural visitors observed in our records, a pace that underscores its deep space origin and the energetic gravitational scatter that likely ejected it long ago from another planetary nursery. Yet velocity does not equal danger. Closest Earth distance remains a roomy 270 million kilometers. For the public that remembers splashy impact stories, the message is simple: this is not that story. For scientists, high speed is not a headline, it's a diagnostic. It shapes grain dynamics, coma evolution, and the cadence with which we must schedule telescopes to keep up. Composition sits at the heart of the 3I story. Each interstellar object is a sample return mission we didn't have to launch. Through spectroscopy, astronomers chase signatures of CN, C, NH, HO, CO, and CO, bands that, taken together, sketch the thermal past of the nucleus. Ratios matter. Compare them to comets from our own Oort cloud and Kuiper belt, and you begin to see whether planet-forming recipes are universal or wildly local. Early hints already show a developing coma and tail, indicators that volatile ices are waking up as solar flux climbs. The promise is that, near perihelion, lines will strengthen, and with them the precision of abundance estimates. That means chemistry across star systems can be compared with a confidence we've not had before. Facilities queue up, Gemini North chalks up observations, Hubble returns at intervals, smaller telescopes provide the all-important cadence between flagship snapshots. It's an orchestra, and 3I Atlas is the score. No interstellar object arrives without a chorus of what IFS. A recent claim argues that 3I Atlas's brightness may be dominated by the nucleus itself, rather than sunlight scattered by surrounding dust, raising, in some tellings, the possibility of an internal power source. From there, the speculative leap, a nuclear-powered craft, a probe skimming our system with deliberate geometry. It's a narrative that travels faster than photons on social media. The scientific community, meanwhile, applies the brake. Extraordinary claims demand extraordinary evidence. Unusual photometry and geometry can have natural explanations: grain sizes, outgassing jets, viewing angles, rotational states, until and unless ruled out. As of now, the consensus remains a comet, with calls for additional observations by Mars Reconnaissance Orbiter, Juno, and others framed as ways to test, not to assume. The healthy posture is curiosity without credulity: take the measurements, publish the methods, reproduce the results. And if nature still refuses to fit, then, and only then, rewrite the chapter. Science loves a timetable. On or about October 3, 2025, 3I Atlas sweeps 0.19 AU from Mars, close enough that orbiters may attempt opportunistic imaging against the crimson backdrop. At the end of October, the object reaches perihelion near 1.36 to 1.4 AU, its fastest and potentially most active phase, before arcing toward a November 3 pass 0.65 AU from Venus. Earth sits out of the front row seats, Our nearest distance arrives around December 19th at roughly $1.80. If weather, geometry, and brightness cooperate, large amateur instruments may tease out the coma as the Sun-comet angle improves, though 3IR Atlas is not expected to become a naked-eye showpiece. For professionals, this is prime time for coordinated spectra and polarimetry. Watch the volatiles yawn, the grains loft and settle, the light curves sway with rotation. Each interstellar visitor is a lesson plan. Oumuamua taught humility about shapes, non-gravitational accelerations, and the perils of late discovery. Borisov, with its textbook coma and tail, gave us a baseline. Interstellar objects can look very much like our own comets. 3IR Atlas threads the needle, clearly cometary, yet with dust behavior and geometry that stretch our priors. Fold these three into a single syllabus and a theme emerges. Planetary systems everywhere probably eject debris efficiently, and the stuff they eject is sometimes familiar, sometimes weird. If 3IR Atlas's chemistry lands close to our averages, universality gets a boost. If it diverges, local histories, stellar type, disk mass, migration drama will write the differences in the spectra. From the first circulars to the first preprints, the velocity of 3IR Atlas is matched by the velocity of its observers. Teams self-assemble across continents, data pipelines spin up overnight, and graduate students discover that dawn calibrations wait for no one. One university story captures the mood, from discovery to paper in days, a sprint that mirrors the object's own haste through our sky. This is modern astronomy: open alerts, public databases, collaborative rivalries, all bent toward extracting maximum knowledge from a fleeting visitor. There's a romance to stepping outside and catching a ghost from another sun with your own optics. Temper that romance with realism. Geometry is destiny. With perihelion still beyond Earth's orbit and minimum Earth distance at ~1. $8, 3IR Atlas was never likely to blaze across suburban skies. Under very dark conditions, large amateur telescopes may pull in a diffuse, challenging smudge, especially as phase angles shift. For most of us, the best views will come not from backyards but from the community of observatories publishing images and spectra, the collective eye of our species focused on a single speck. As 3IR Atlas rounds the sun and heads outbound, models predict changes in gas production, dust velocities, and coma morphology. If some of the early oddities were geometric illusions, they'll fade with changing angles. If they're rooted in intrinsic physics, layered crusts, jet vents, fragile aggregates, we'll see signatures persist, evolve, or bifurcate in telltale ways. By early 2026, after the Jupiter pass, the data set will be rich enough to anchor comparative planetology across star systems. Each number entered into a table, line strength, color index, AF, will tighten our grasp on how common it is for distant nurseries to build, bake, and fling small worlds. And then it will be gone, a dim outbound whisper, leaving its information behind like a wake on a black sea. Why chase a mote through infinity? Because every comet is a lab, and every interstellar comet is a lab built to a different code. 3IR Atlas is not just a curiosity, it is a calibration point for the galaxy. If its chemistry rhymes with ours, the rhyme suggests universality in the recipes that build oceans and atmospheres. If it does not, the dissonance tells us where and how planetary systems improvise. Either path enriches the score. In the long ledger of questions, about our origins, about life's odds, about the commonness of Earth-like outcomes, 3IR Atlas buys us a few honest entries. That's worth the vigilance, the late nights, the fast papers, and the patient calibrations that turn a faint smudge into knowledge. Every interstellar traveler has a birthplace, but that birthplace is not easily traced. When 3IR Atlas was discovered, astronomers immediately began to rewind its orbit, running computer simulations backward through time. The mathematics says this: the object came at us from a direction near the galactic plane, but beyond that, the uncertainty explodes. Over millions of years, tiny gravitational nudges from stars and clouds of interstellar gas scramble paths into anonymity. Yet, probabilities remain. Some models suggest 3i Atlas may have originated in a disk around a star not unlike our own, one that tossed icy bodies outward during its planet-forming chaos. Others propose a giant planet gave it the final gravitational kick, hurling it into interstellar exile. Unlike meteorites, which can sometimes be traced to the Moon or Mars by isotopic fingerprints, this visitor comes with no return address. And that is part of the wonder. Every measurement we make of its dust, its gases, its behavior, is not just about the object itself, but about the unseen system that built it long before humans first lit fires on Earth. Why do scientists treat 3i Atlas with such reverence? Because it is a time capsule. Comets are the deep freezers of planetary systems, small enough to avoid the violent melting and differentiation that turn larger bodies into planets. Inside their nuclei, ices can remain locked away for billions of years, unchanged since the dawn of their home system. Imagine cracking open a vault from another star and finding out what its protoplanetary disk was made of. That is the opportunity here. If 3i Atlas carries water ice, we can compare its isotopic ratios to those of Earth's oceans. If it shows exotic molecules, like carbon chains, nitriles, or complex organics, those can tell us whether the chemistry that seeds life is rare or universal. We are not simply studying a speck of ice and dust. We are interrogating the cosmic pantry of another sun. The question is no longer just what 3i Atlas is made of. The deeper question is, how similar are the building blocks of distant worlds to the ones that built ours? Pause for a moment and consider the geometry. Space is vast beyond comprehension, and yet, here is a body no more than a few kilometers across threading the solar system in 2025. The odds sound astronomical, because they are. Yet planetary systems eject trillions of such bodies during their formation. Most wander forever in the interstellar dark, unseen, unlit. A handful, by coincidence, cut through the narrow ribbon of volume we occupy. Earth, with its telescopes, acts as a kind of cosmic fishing net. In a century of scanning, we have caught 3 such objects: Oumuamua, Borisov, and now Atlas. Statistically, that suggests billions upon billions more are drifting between stars. Each one is an unknowing ambassador, proof that planetary systems do not hoard their small debris. The solar system, it turns out, is not unique in shedding its icy crumbs to the galaxy. The geometry of chance is, paradoxically, what makes these discoveries inevitable. Catching a ghost from another sun requires more than luck, it requires engineering. The survey telescopes that spotted 3i Atlas are designed with wide fields of view, automated software pipelines, and rapid response teams. Once the candidate was flagged, observatories worldwide began to pivot, both literally and figuratively. Scheduling time on premier instruments like the Hubble Space Telescope or the giant mirrors of Mauna Kea requires coordination, funding, and sometimes political agreements. Amateur astronomers also joined in, providing critical continuous monitoring while larger facilities dealt with competing priorities. The infrastructure of global astronomy becomes a living organism when such a visitor arrives. Data flowing across continents, analysis scripts running overnight, alerts spreading like wildfire in professional networks. Behind every sharp image of 3i Atlas is a hidden web of cables, servers, and human cooperation. It is easy to imagine the object as an isolated traveler, but in truth, its presence has already bound together thousands of people on Earth into a collective act of observation. Every solid body spins. Some rotate swiftly, completing a turn in mere hours, others take days or weeks. For comets, rotation is more than motion, it is destiny. A nucleus that rotates unevenly will vent gas and dust in shifting directions, producing tails and jets that flicker or even flip. With 3i Atlas, astronomers are piecing together a light curve, a faint variation in brightness as the object rotates and presents different surfaces to the Sun. Early results hint at a rotation period measured in hours, but the details remain uncertain. The intrigue is in the irregularity. Dips that don't quite repeat, suggesting either an elongated shape or complex activity patterns. If jets emerge from vents on different faces, the rotation could cause its dust to spray in spirals, sometimes appearing forward, sometimes backward. Imagine a garden sprinkler in deep space, spinning not by design but by billions of years of inertia. By tracking those flickers, astronomers can deduce shape, stability, and whether the nucleus is tumbling chaotically, like a poorly thrown dart. Such dynamics matter. They tell us about internal strength, cohesion of ices, and the history of collisions. In short, the rotation of 3I Atlas is the choreography of its life story. White light hides secrets. Break it apart, and a rainbow spills out, filled with coded messages. Spectroscopy is astronomy's decoder ring. When telescopes catch the light from 3I Atlas, they split it into wavelengths. Their faint notches and spikes reveal molecules. Cyanide glowing blue, diatomic carbon shining green, water vapor breathing infrared. Each emission line is a fingerprint, proof that the chemistry of another system has stepped briefly into ours. Already, spectrographs show the comet waking up, icy grain sublimating, gas swelling into a coma. By comparing the ratios of these molecules, scientists can ask, how does this body compare with comets native to our Oort cloud? Does it carry the same abundance of carbon monoxide, or is it depleted? Does its water bear heavy isotopes that differ from Earth's oceans? Every answer feeds the larger narrative. Is the galaxy filled with chemical common ground, or do systems diverge wildly in their recipes? And behind every spectral line lies something more profound, the possibility that the molecules of life, simple organics, precursors to amino acids, are not confined to our cosmic backyard, but wander freely between stars. Comets are not neat travelers, they shed. As 3I Atlas draws closer to the Sun, it leaves behind a trail of dust, each grain a breadcrumb marking its path. That trail is no static streak. The solar wind sweeps it, radiation pressure bends it, planetary gravity perturbs it. If one could zoom out and accelerate time, the effect would be mesmerizing, a ribbon that unfurls, twists, and lengthens with each passing day. These trails are not just aesthetic, they hold physics within them. The thickness of the dust, its brightness, and the angles of dispersal tell us about particle sizes and release velocities. Some models predict that Atlas may leave a stream dense enough that, decades or centuries from now, another planetary system, or perhaps even ours, if orbits align, could pass through it, igniting a meteor shower. Imagine that, starlight-borne dust falling into alien skies. Right now, in 2025, the grains are still close to their parent. But astronomers watching from Earth treat them as vital tracers. Each mote of dust carries not just mass, but memory, the memory of a violent expulsion from a distant nursery long ago. When Oumuamua was discovered in 2017, it felt singular, almost miraculous. Then, 2 years later, Borisov appeared, proving the first was no fluke. Now, with Atlas, a pattern emerges. The archive of interstellar objects is expanding. Each one broadens the spectrum of what these wanderers can be: elongated shards, comet-like bodies, dust-rich travelers. Statistically, this suggests the galaxy is swarming with them. Our telescopes are finally just sensitive enough to catch a fraction. The archive is not just a list of names, it is a growing dataset, a comparative atlas of planetary debris across the Milky Way. In time, with enough examples, astronomers will plot distributions, sizes, speeds, chemical compositions. The aim is to answer sweeping questions: do most systems fling out comet-like bodies, or are they rare? Do certain star types eject more debris than others? Are interstellar rocks more often icy or dry? Atlas, as entry number 3, may not provide the final word, but it deepens the catalogue and ensures that the story is no longer anecdotal. The interstellar archive has begun, and Atlas is another page in that unfolding book. It is easy to drown in numbers, eccentricity, perihelion distance, AF values. But beneath those numbers lies a human response as old as stargazing itself: wonder. When news of 3I Atlas broke, it rippled beyond observatories. Headlines declared the arrival of a visitor from another star. Teachers used it in classrooms to remind students that the universe is alive with motion. Amateur astronomers charted its path, hoping to glimpse it through their backyard telescopes. Even those with no telescope at all found meaning in the idea. Somewhere, across impossible gulfs of space, a small body had been ejected by forces we may never see, only to cross paths with our species in its brief moment of technological vigilance. For humanity, still new to the cosmos, this is a mirror, proof that we are not isolated, that the universe is not static, and that stars exchange fragments of themselves without ever knowing it. We are watching not just an object, but a message that planetary systems talk to each other, not with words, but with debris. And we, tiny, listening, have finally learned to hear. When a comet from another star enters our system, the first question for engineers is not what is it, but can we reach it? In the case of 3I Atlas, that dream was immediately alive. Teams sketched scenarios: a rapid-fire probe launched within months, small and nimble, riding on an existing rocket to chase the visitor. Yet reality struck. Atlas moves too quickly, nearly 60 kilometers per second relative to the Sun, and the warning too short. To intercept, a spacecraft would need extraordinary delta-v, far beyond what our chemical rockets can deliver on such short notice. Some proposals suggested piggybacking on gravitational assists, others hinted at nuclear propulsion or solar sails, but all required years of planning we simply did not have. The dream of a flyby faded, replaced by the resolve to learn as much as possible from afar. And yet, the exercise was not wasted. Each missed opportunity strengthens the case for a standing mission, a probe already built, waiting, ready to sprint after the next interstellar visitor. One day, perhaps decades from now, a spacecraft will not just watch from afar, but will close the gap, cross the void, and photograph alien ices up close. 3I Atlas reminds us that the future demands readiness. The velocity of 3I Atlas is not just a challenge for spacecraft, it is a lesson in cosmic violence. Bodies like this do not drift gently from their stars, they are ejected with fury. Imagine a young planetary system, giant planets migrating inward and outward, scattering smaller bodies like billiard balls. Some are cast inward toward their star and destroyed. Others are flung outward, accelerated beyond escape velocity, and doomed to wander the galaxy. The speed of Atlas, nearly twice the orbital velocity of Earth, is testimony to such chaos. It has likely been traveling for millions, even billions, of years through interstellar darkness. Along the way, its surface has been battered by cosmic rays, its ice is altered by ultraviolet light, its orbit tugged microscopically by passing stars. By the time it arrived here, it was both ancient and scarred, a fossil in motion. For scientists, speed is not just a number, it is a clue to the violence of birth, the energy of exile, and the enormity of time across which such exiles roam. October 2025 holds a quiet drama. 3I Atlas will pass within 0.19 astronomical units of Mars. To the casual ear, that sounds distant, but in celestial terms it is close, about 70 times the gap between Earth and the Moon. For the fleet of robotic explorers circling Mars, it is a rare gift. Cameras aboard orbiters may attempt to catch the faint streak of the visitor against the Martian sky. Instruments designed for studying dust in the thin atmosphere could record slight upticks if stray particles intersect. Though no collision is expected, the encounter is symbolic: two worlds, both wanderers in their own right, sharing a fleeting proximity to a traveler from beyond. Scientists anticipate that even a handful of images from Mars' orbit would offer a perspective impossible from Earth, free from atmospheric distortion and at an angle unique in the solar system. In the archives of planetary science, such moments become treasured: the chance to triangulate, to see the same object from two vantage points, to turn observation into stereo vision across interplanetary space. A week after perihelion, Atlas sweeps past Venus at about 65 cents. The planet itself, cloaked in its eternal clouds, cannot witness the event, but instruments orbiting nearby might. As the comet rounds the Sun and begins to recede, its activity may shift. Gases that surged at perihelion begin to wane, jets that burned brightly sputter as sunlight diminishes. Dust trails elongate, their density thinning into the void. For astronomers, this phase is as important as the inbound leg. Outbound evolution reveals how fast volatiles are exhausted, how the surface crust reacts after its brief warming, and how long a coma can survive once its energy source weakens. In the fading glow, scientists glimpse resilience, or fragility. Will Atlas maintain a tail far from the Sun, like Borisov did, or will it sputter quickly into invisibility? Every telescope trained on the outbound leg is seeking that answer, because it tells us about not just this object, but about the endurance of cometary bodies born under alien suns. At each stage, 3i Atlas has resisted simplification. First it seemed small, then perhaps larger. First its dust appeared ordinary, then it seemed to flow sunward. First it promised a predictable brightening, then it flickered and puzzled. These contradictions are not failures of science but its essence. Each misfit observation is a message that our models, forged on local comets, may not always apply universally. Perhaps Atlas holds ices with unusual thermal properties. Perhaps its nucleus is layered, crust over crust, like an onion of different histories. Or perhaps its oddities are simply illusions of angle and timing. What matters is not the difficulty but the persistence. Astronomers will refine models, adjust assumptions, and return to the data again and again. In the end, Atlas will yield its story, not all of it, but enough to expand the map of what interstellar objects can be. Ordinary it is not. Nor should we expect it to be. After all, how could a body cast out of its birthplace, wandering for eons, and arriving uninvited at our Sun ever be anything less than extraordinary? Every interstellar discovery reignites the debate, should we be ready, next time, to launch? 3i Atlas, like its predecessors, arrived with only months of warning. In cosmic terms, that is the blink of an eye. To chase such an object, spacecraft must already exist, waiting in cold storage or cruising in standby orbits, ready to ignite their engines the moment the alert comes. Some proposals suggest a comet interceptor strategy, small, modular probes parked near Earth Lagrange points, able to spring into motion with little notice. Others imagine fleets of solar sailcraft, constantly tacking through the inner system, able to adjust course when the call arrives. Atlas has underscored the urgency. Interstellar comets are not rare curiosities, they are regular phenomena, and to capture one up close is to hold in our instruments a piece of another star's nursery. The question is no longer whether we can afford to prepare, but whether we can afford not to. For each missed chance, centuries may pass before another opportunity aligns with technology and readiness. The future belongs to those who wait prepared. Consider the chemistry carried in 3i Atlas. Water, carbon, cyanides, perhaps even more complex organics. To most, these are mere molecules. But in the grand equation of life, they are syllables in the universal alphabet. If Atlas carries nitriles, formaldehyde, or simple sugars, then it confirms what some theories propose, that the ingredients of biology are not confined to a few lucky systems, but are strewn across the galaxy by comets. Earth's own history may have been seeded this way, oceans, and life sparked by gifts from icy bodies. Now imagine this process happening everywhere, across thousands of star systems, billions of planets. Interstellar comets like Atlas are not just debris, they are couriers of possibility. They whisper that the chemistry of life may not be unique, but common, part of the natural rhythm of matter. Even if no single molecule on Atlas will ever touch our soil, the fact that we can detect them at all, parse them from across millions of kilometers, is a triumph. It transforms a speck of dust into a messenger, carrying news from another sun. When you look at Atlas, faint in the eyepiece, you are seeing a body that has endured billions of years of exile. Its surface has been scarred by radiation, hydrogen atoms stripped, organic bonds broken, ice is compacted into strange, dark crusts. To human eyes, it may appear as a soft smudge, a pale cloud. But beneath that cloud lies an archive. Every crater, every fracture, every layer of frost tells a story of survival in interstellar night. In its long wandering, Atlas has passed through regions of differing densities, quiet voids, turbulent clouds, the outskirts of stars. Each environment etched itself into its skin. Now, in 2025, we are witnesses to its unveiling. For a few months, it glows, illuminated by our sun, its coma fanning out like a fragile veil. And then, as quickly as it appeared, it will dim, vanish, and continue outward. Our role is brief, but profound, to bear witness, to record, and to remember that for the first time in human history, we are capable of noticing such scars on a body from another sun. Throughout history, comets have been omens. They blazed across skies, inspiring fear, awe, and prophecy. Now, in the scientific age, we know their nature. But 3I Atlas reawakens the older instincts, a visitor from beyond, untethered to our star, evokes something deeper than astronomy. For poets, it is a metaphor of exile and return. For philosophers, a meditation on impermanence and chance. For storytellers, a symbol of messages carried silently across gulfs of space. Even in popular culture, Atlas has begun to appear, an emblem in art, a spark for speculative fiction, a subject for countless conversations online. Science describes what it is, but culture gives it meaning. This is the double life of interstellar visitors, physical objects obeying physics, and symbols that awaken myth. As with Halley's Comet, which tied itself to history with its predictable returns, Atlas will tie itself to memory, not through recurrence, but through its uniqueness. It is a comet, yes. But it is also a mirror, showing us how humanity projects story onto the cosmos. When its brief rendezvous ends, Atlas will recede into the black. Beyond 2026, it will vanish into the deep sky, too faint even for the largest telescopes. From there, its journey continues, untracked, unobserved, but unending. For millions of years, perhaps billions, it will drift outward, past stars, through nebulae, across the galaxy's spiral arms. It may pass close to another system, perhaps drawn for a moment into their outskirts, offering itself again as a comet to alien astronomers who, like us, wonder if they are alone. Or it may wander endlessly, never again approaching a sun, its nucleus frozen in eternal night. To think of such scales is humbling. Our entire species has existed for only a breath of its lifetime, yet for this brief intersection, our paths have crossed. We observed, measured, and imagined. And then we let go. Atlas continues its story without us. But we, for having seen it, are changed. When we study 3I Atlas, we are not only observing a comet, we are peering into the blueprint of planetary systems. Comets preserve the chemistry of their birthplaces, carrying mixtures of volatile ices and primordial dust. In our solar system, they whisper stories about the cold outer regions where planets never fully formed, fragments cast adrift by the gravity of giants like Jupiter. Interstellar comets expand this laboratory. They are the controls in a vast cosmic experiment. If the ices in Atlas resemble those of our comets, it suggests that nature repeats itself. Planetary systems across the galaxy bake from the same recipe. But if its chemistry diverges, then variety is the rule, and planetary systems are individual, each with its own signature. That distinction matters. It shapes the likelihood of habitable worlds, the odds of liquid water, and even the probability of life. Each molecule identified in Atlas's coma is more than a chemical clue, it is a data point in the grand survey of creation. The comet is not a curiosity but a chapter in the origin story of planets everywhere. Even as we celebrate each pixel captured and each spectrum drawn, we are reminded of the limits of human technology. The comet is faint, smaller than the margin of error in many calculations. The best telescopes on Earth and in orbit stretch their sensitivity to catch its glow. Signals are weak, exposure times long, and analysis requires careful subtraction of noise. What we wish we could see: craters on its surface, the precise geometry of jets, the exact isotopic fingerprints of its water, is blurred by distance and dimness. Our instruments reveal much, but not all. The frustration is real, we are glimpsing a miracle, yet through frosted glass. Still, every photon counts. And with each new visitor, technology advances. Future observatories, larger mirrors, sharper spectrographs, perhaps even fleets of space-based instruments, will transform faint smudges into detailed portraits. Atlas reminds us that astronomy is a pursuit balanced between awe and insufficiency. It is humbling to know that even in an age of giant telescopes, the universe still offers mysteries that strain our reach. Atlas is not alone. It is one of countless billions of interstellar objects adrift in the galaxy. Ejected from their nurseries, they roam endlessly, silent witnesses to stellar histories. Some pass close to stars, briefly igniting comas as they warm. Others wander eternally in cold darkness, invisible save for rare chance alignments. To imagine this population is to realize that interstellar space is not empty. It is littered with the fragments of creation, failed planets, shattered bodies, icy shards like Atlas. Perhaps every star sheds such remnants, forming an unseen river of cosmic debris flowing through the Milky Way. We see only those few that intersect our skies. But if our instruments could reveal them all, the galaxy would blaze with unbound comets, more numerous than the stars themselves. Atlas is a reminder that the universe is dynamic and restless. Stars build, stars scatter, stars give away their fragments. And we, standing on our small planet, are finally able to notice the drift of wanderers between suns. For most of human history, such a visitor would have gone unnoticed. Our ancestors saw only the comets bound to the sun, portents in their skies. The faint smudge of Atlas, hidden against the stars, would have been invisible without glass and mathematics. That we now detect it is a measure of how far we've come. Yet, in cosmic time, this ability is brand new. If human civilization lasts for millennia, future generations may record hundreds, even thousands, of interstellar visitors. Atlas will then seem like one of the first, an early chapter in a long catalogue. But for us, in this moment, it is unique. We are the first generation to witness such objects, to confirm that debris truly travels between stars, and to place that fact into the story of our origins. The irony is beautiful. The comet has been traveling for millions of years, and only now, only in this slim window of human technological adolescence, did we have the means to see it. The universe is ancient, yet it chose this moment, this century, to let us know. When Atlas fades from sight, it will leave behind more than memory. It will leave data. Terabytes of images, spectra, light curves, and models. That archive will outlast the comet itself in our skies. Long after it has vanished into the dark, scientists will return to the numbers, comparing them with future discoveries. Each dataset becomes part of a chain, a growing library of knowledge that stretches across decades. Even if Atlas itself is never seen again, its scientific echo will remain. Papers will be written, theories tested, simulations refined. In classrooms, its discovery will be retold, not as a fleeting curiosity, but as part of the expanding science of interstellar bodies. And somewhere, perhaps a century from now, when humanity intercepts another visitor up close, the data from Atlas will be pulled from archives, compared, and used to measure how far we have come. The comet may wander on, silent and indifferent, but here on Earth, it has already inscribed itself into our collective legacy. The story of Atlas fuels more than curiosity. It fuels engineering blueprints. Imagine a spacecraft waiting in deep space, solar panels angled, hibernating until a discovery alert awakens it. Within hours, it calculates a course, ignites propulsion, and races to intercept a visitor. This is not fantasy. Design studies exist today. Concepts range from ion engines that sip fuel while building speed, to solar sails that ride the constant push of sunlight, to nuclear-powered stages with thrust enough to chase objects even at tens of kilometers per second. What is missing is not technology alone, but commitment. Atlas has reminded us that opportunities come suddenly and vanish just as quickly. A standing mission, a sentinel in the void, would ensure that the next interstellar object is not only observed from afar but touched, sampled, even photographed up close. One day, we may return material from such a comet to Earth, holding in our laboratories grains of another solar system. For now, Atlas serves as the rehearsal, a motivator to prepare for the encore. For centuries, we imagined stars as distant islands, each isolated in a dark sea. Atlas, and objects like it, demand a new mental map. The galaxy is not a clean divide between systems. It is threaded with debris, a web of icy messengers drifting from one nursery to another. When planetary systems form, they do not remain self-contained, they shed fragments that wander forever. This realization changes our understanding of cosmic ecology. It suggests that stars do not evolve in isolation, they trade dust and ice, they exchange ingredients, they may even spread life's precursors across the spiral arms. The Milky Way, then, is less like an archipelago of islands and more like a connected ocean, where currents carry driftwood between distant shores. Atlas reframes our galaxy not as a collection of closed systems, but as a living network of matter in motion. And in that network, Earth itself may one day become both recipient and donor, sending fragments of our own into interstellar exile. Every dataset we collect on Atlas is precious precisely because it is fragile. The comet will fade. The chance will not return. If an observatory misses its window, that data is gone forever. Astronomy is often a science of patience, tracking stars over centuries, waiting for rare alignments, but in moments like this, it is a science of urgency. Instruments must be booked, teams must respond, weather must cooperate. The comet will not wait. This urgency sharpens focus, galvanizing international cooperation and binding scientists together across borders. Yet it also reminds us of the precariousness of knowledge. We are always one missed observation away from ignorance. The fragility of our knowledge is not a weakness, but a challenge, a call to build better readiness, broader networks, and faster responses. Atlas is more than a comet. It is a test of our ability to capture fleeting truths before they vanish back into the cosmic night. There is something profoundly humbling in gazing upon Atlas and realizing it has traveled farther than our species has dreamed. Its journey may have begun before Earth's continents reached their modern shapes, before mammals diversified, before humans even existed. And yet, across the gulf of time and distance, our paths intersected. In that fleeting intersection, we glimpsed the infinite, the reality that the galaxy is alive with movement, with countless unseen bodies threading their own arcs. Atlas is a comet, yes, but it is also a glimpse of scale. It reminds us how small we are, how brief our history is, and how vast the cosmos continues to be. The infinite is not abstract, it is embodied in this single smudge of light, moving relentlessly through our system and beyond. It whispers that the infinite is not somewhere else, but here, passing silently in our skies, if only we choose to look. Why does Atlas matter to us so deeply? Why do we feel awe, even when the data is faint and the comet invisible to naked eyes? Because in it we see ourselves. We, too, are travelers in the galaxy, bound for now to our sun, but not forever. Someday, fragments of Earth will be ejected, rocks launched by impacts, spacecraft pushed into endless orbits, perhaps even probes designed to carry our message. We, too, will become wanderers, drifting between stars. Atlas is a preview of that fate. It forces us to ask, what stories will our fragments carry? What chemistry, what signals of our existence will others find? In watching an interstellar visitor, we are rehearsing for our own role in the grand exchange of matter. Atlas is not just science. It is existential reflection. It reminds us that to be human is to seek connection, and that in the vast silence of the galaxy, even a comet becomes a conversation partner. When Atlas was announced, something rare occurred. Astronomers from every corner of the globe turned their eyes toward the same target. In South America, wide-field survey telescopes tracked its faint glow. In Europe, spectrographs picked apart its colors. In Asia, radio dishes listened for subtle signatures of gas. In orbit above Earth, space telescopes captured its evolving coma. Each continent added a note, and together they formed a symphony of observation. In a time when humanity often feels divided, the sky still unites us. No border can block starlight, no politics can prevent photons from falling equally on all lands. Atlas becomes not just a comet, but a reminder of our shared place under one sky. Every spectrum, every image is archived not for one nation, but for all. Long after Atlas departs, the story will remain a global one. Written by humanity as a whole, not any single hand. We live by hours, days, and years. Atlas lived by millions. Its ejection from its home star system may have coincided with the formation of our own solar system. Its journey could have lasted through entire cycles of galactic rotation, passing silently between spiral arms. Against such scales, human history is but a blink. Civilizations rise and fall while Atlas drifts onward, indifferent. Yet, paradoxically, it is in that indifference that we find meaning. For the comet does not care who sees it, yet we care. We measure, we record, we imagine. By doing so, we bridge the gap between eons and moments. Time, stretched across billions of years, finds resonance in our brief human lives. The comet reminds us that even fleeting observation can anchor us to eternity, that our ability to notice is itself a triumph against the vast indifference of the cosmos. Atlas is never close. Even at its nearest, it will remain nearly 270 million kilometers from Earth. Yet it teaches us the value of distance. To see something so far and faint reminds us of the sensitivity of our instruments and the precision of our mathematics. With nothing more than light gathered across a void, we deduce speed, size, and composition. It is a triumph of inference, a discipline of humility. We are reminded that knowledge does not always come from touch or proximity. Sometimes it comes from careful listening to whispers across great chasms. Distance also protects us. Unlike near-Earth asteroids, Atlas poses no danger. We can observe with curiosity rather than fear, letting its remoteness free us to think not about survival but about wonder. In this way, distance becomes not an obstacle, but a teacher. It shows us that the universe can be both unreachable and knowable at once. There is an irony in our fascination with Atlas. While it wanders the galaxy, so do we. Earth, too, is an interstellar traveler, orbiting the Sun as the Sun itself drifts through the Milky Way. We are already on a voyage across the stars, though our perspective blinds us to it. Interstellar comets simply remind us of what we already are, wanderers. And one day, fragments of Earth will truly join that wider current. A great impact could launch rocks from our planet into escape trajectories, carrying microbes or fossils into eternity. Human spacecraft, too, will drift forever, Pioneer and Voyager probes already outbound, their golden records waiting for eyes that may never come. We are not separate from the river of debris that threads the galaxy, we are part of it. Atlas is a mirror, showing us our own fate written ahead of time. Imagine the far future. Civilizations rise around distant suns, with their own telescopes and their own questions. One night, their astronomers spot a faint moving point. They calculate its orbit and declare an interstellar visitor. They split its light into spectra, detecting traces of metals, minerals, and isotopes. In time, they realize the truth: it came from another system, long ago. Perhaps it is even from ours. Perhaps a rock ejected from the Oort cloud, or a probe cast into the stars, drifts past their world. To them, it is what Atlas is to us, a messenger, uninvited but priceless. The cycle continues, civilizations catching each other's fragments across the gulfs of space and time. In this way, Atlas is not only an object in our present, it is a symbol of what the future will hold. A galactic conversation, spoken not with voices, but with matter itself, drifting endlessly between stars. There is a deep, almost primal resonance in the idea of a visitor from beyond. Even when 3i Atlas is invisible to human eyes, the knowledge of its passage stirs something ancient within us. For millennia, humans looked to the sky with a mixture of fear and reverence. Comets were seen as omens, heralds of change. Today we understand their physics, yet the feeling lingers. The idea that an object from another star is here, passing through our solar system, awakens both curiosity and unease. It confronts us with the reality that the cosmos is not distant and still, it is active, dynamic, filled with movement. For many, this is exhilarating, for others, unsettling. Psychology teaches us that meaning often comes from encounters with the unfamiliar. Atlas is the unfamiliar made manifest, a reminder that our sense of cosmic security is temporary, and that the universe holds more surprises than we dare imagine. Science thrives on both competition and cooperation, and Atlas brings out both in equal measure. Around the world, research teams scramble to publish the first results, orbital solutions, brightness curves, spectroscopic detections. Academic prestige hangs on being first, yet beneath the rivalry lies a deeper cooperation. Data must be shared quickly, observatories must coordinate, and analysis pipelines must remain transparent. The comet moves too swiftly and fades too quickly for secrecy. In this way, Atlas becomes a crucible where human ego and human unity meet. The rivalry drives precision and speed, the cooperation ensures completeness. Together, they generate a record far richer than any isolated effort could achieve. The comet itself, indifferent to our ambitions, sails onward. But in its wake, it leaves not just measurements but also the example of how science, at its best, can turn competition into collective discovery. We often think of Earth as our home, the solar system as our neighborhood, and the galaxy as the distant beyond. But Atlas blurs those boundaries. Its presence here suggests that no system is truly closed, no star an isolated world. Instead, home is porous. Material drifts in, material drifts out. To know that our solar system receives visitors, and likely sends them, changes what home means. It is no longer a sealed chamber, but a crossroads. Some find this disquieting, as though it diminishes the uniqueness of our system. Others find it comforting, proof that we are part of a larger cosmic fabric. Either way, the definition of home expands. It is not Earth alone, nor the solar system alone, but the galaxy itself. Atlas teaches us that we are residents not of one system, but of a universe in which matter is forever exchanged, traded, and shared. Whenever an interstellar object appears, whispers follow, could it be artificial? The idea is irresistible. A probe from another civilization, skimming through our skies, cloaked as a comet. With Atlas, as with Oumuamua, speculation has flared. Its brightness, its dust behavior, its speed, each anomaly invites theories. And while science insists on natural explanations first, the speculation itself is telling. It reveals our hunger for connection, our readiness to believe we are not alone. Whether or not Atlas is artificial is almost beside the point, the fact that we ask the question shows how much we yearn for contact. For now, the evidence points firmly to natural origins. But the conversation itself is part of the comet's legacy. It sits at the intersection of data and dreams, reminding us that the human response to the cosmos is always both analytical and imaginative. Beyond numbers, Atlas is a narrative. A body born around another star, exiled by gravitational chaos, cast into the dark for eons, and now, by chance, passing through our system. It is a story of origin, loss, wandering, and fleeting reunion. Like all stories, it resonates because it mirrors our own. We, too, are products of cosmic origin, exiles in our own way, wandering the galaxy aboard a fragile planet, seeking meaning in our brief journey. By turning Atlas into a story, we humanize it, not to diminish its science, but to expand its significance. For science and story are not enemies, they are partners. Data tells us what Atlas is, story tells us why it matters. And in the end, both are true. The comet will fade, but the story will remain, passed on in classrooms, documentaries, and human memory, proof that even in the infinite cold of space, meaning is something we create together. We often think of archaeology as the study of buried cities and ancient tools, but the term reaches farther. With Atlas, astronomy becomes archaeology on a galactic scale. Each grain of dust, each molecule in its coma is an artifact, a remnant of a system long gone or far away. By analyzing its composition, we are excavating the ruins of another world's creation. This is not the archaeology of stone and pottery, but of ice and carbon chains, relics preserved for billions of years in the cold. Just as shards of clay reveal how ancient people lived, shards of Atlas reveal how alien stars once forged planets. Interstellar archaeology is young, but it is profound. It treats the galaxy itself as a field site, with each comet a relic waiting to be uncovered. Atlas is one of the first artifacts catalogued in this vast archive, but it will not be the last. In time, we may reconstruct entire histories of planetary systems from such relics, rewriting our place in the cosmic museum. Science advances through measurement, but imagination provides the spark. Atlas inspires both. Observers catalogue its orbit, but children imagine it as a messenger from distant civilizations. Researchers refine models of its dust tail, while artists sketch it cutting across alien skies. Both acts matter. Imagination widens the horizon, daring us to ask questions that data alone might never suggest. Could interstellar objects spread life between stars? Could civilizations deliberately launch probes disguised as comets? Could humanity one day send its own Atlas-like wanderers outward, carrying stories of Earth? Each of these begins as speculation, yet speculation often seeds discovery. The comet is real, but the meaning we layer upon it is a fusion of evidence and vision. And in that fusion lies progress, the courage to turn cold data into warm possibility, and to see not just what is, but what might be. Every interstellar visitor awakens the same longing. If a comet can cross the gulf between stars, why not us? Atlas has traveled distances we can scarcely comprehend, carrying with it the chemistry of another world. Humanity dreams of doing the same. Our spacecraft, Voyager, Pioneer, New Horizons, are already outbound, humble emissaries of Earth. They lack the speed of comets, but they carry messages, golden records, data plaques, signs of intelligence. Atlas reminds us that travel between stars is not impossible. It has happened countless times, naturally, for eons. The difference is scale. We are bound by technology, comets are bound only by physics. Yet the sight of Atlas is encouragement. Nature has already solved the journey. Our task is to learn how to follow. Someday, perhaps, ships of human design will wander as Atlas does, bearing not silence, but voices, songs, and memories. Until then, the comet is our teacher, showing us that interstellar passage is not a dream, but a fact of the universe. What if we had missed it? If clouds had hidden the survey skies on that night in July, Atlas might have slipped by unnoticed. The thought is sobering. How many interstellar visitors have come and gone, unrecorded, unseen? Perhaps dozens in the past century, perhaps hundreds across human history. Atlas reminds us of the fragility of witness, that our awareness is not guaranteed, but earned through vigilance. Each telescope, each survey program is not just a tool of science, but a defense against ignorance. By catching Atlas, we expand the known. By missing others, we remain blind to what passed above us. Awareness is fleeting, fragile, easily lost. That fragility gives weight to the discovery. It reminds us that every observation matters, and that even a faint speck on a survey image can change our understanding of the cosmos. One day, Atlas will be gone from our skies, its faint trail swallowed by distance. Humanity may forget its details, but the comet story will continue elsewhere. Perhaps it will pass near another star, igniting again under new sunlight, and be seen by alien astronomers. Perhaps it will be catalogued by a civilization yet unborn, treated as a precious clue in their own search for origins. The story of Atlas is larger than humanity. We are but one chapter in its journey, one species that happened to notice. The comet's true story stretches across billions of years and trillions of kilometers, linking worlds we will never see. To know this is to accept humility. We are not the center of its narrative, only participants for a moment. Yet even that moment is enough. For in noticing Atlas, we have inscribed ourselves into its journey, and it into ours. For centuries, we looked at the stars and imagined them as unreachable lanterns, each system sealed in solitude. Atlas defies that notion. It is proof that the galaxy is not made of islands, but of archipelagos linked by drifting bridges of rock and ice. We are not alone in the sense that fragments of other systems already pass among us. They may not carry messages, but they carry presence. Cosmic isolation, once assumed, dissolves. We exist in a galaxy where systems talk not with words but with debris, where stars shed pieces of themselves and those pieces wander into other skies. Atlas tells us that we are participants in an ongoing exchange, recipients of matter not born under our sun. The barrier between us and them has already been crossed. Isolation was never true, it was only our blindness that made it feel so. The discovery of Atlas feels like chance, a faint dot noticed on one survey night, one trajectory intersecting our neighborhood by coincidence. But in the mathematics of the galaxy, it is inevitable. Millions of such bodies drift through interstellar space. The solar system sweeps along its orbit around the Milky Way, intersecting their paths as surely as a ship crossing an ocean encounters driftwood. The paradox is profound. Each individual visitor is a chance event, yet the occurrence of visitors itself is inevitable. This duality echoes human life. Each meeting we experience is coincidence, yet the fact of meeting is certain. Atlas embodies this dance of chance and inevitability. It was not destined to meet Earth, yet some interstellar comet was bound to. In its arc through our system, we see the quiet mathematics of the cosmos, randomness written into certainty, chaos woven into law. We are drawn to Atlas because we recognize ourselves in it. Like the comet, humanity is a wanderer. We left Africa to populate the globe, crossing oceans and deserts. Each migration carried fragments of culture, language, and memory, just as Atlas carries fragments of its star. Today, we prepare to leave Earth itself, sending probes to the outer planets, dreaming of interstellar voyages. The comet is a mirror, cast out from its origin, crossing unknown expanses, encountering new horizons. Its journey is solitary, ours collective, but the symmetry remains. Both comet and humankind are wanderers by nature, driven outward, compelled by forces both physical and psychological. When we watch Atlas streak through the solar system, we are watching a reflection of our own destiny, written in ice and motion. The universe is patient beyond measure. Atlas has wandered for millions of years to arrive in our skies for a season measured in months. This mismatch of timescales is staggering. What for the comet is a blink, for us is a revelation. And yet, the universe waits. It does not hurry. It allows bodies like Atlas to drift until they are found, if they are found at all. Our role is not to command the cosmos, but to align our brief span of awareness with its slow unfolding. To see Atlas is to learn patience, that truth sometimes takes eons to arrive, that stories may linger in silence before being noticed, and that meaning comes not from speed but from endurance. The patience of the universe humbles us, but it also comforts us. It tells us that discovery is always possible, no matter how vast the delay. What is Atlas if not a sentence spoken by the universe? Its orbit is the grammar of gravity, its dust the vocabulary of chemistry, its faint glow the punctuation of sunlight. We read it as text, deciphering its syntax with telescopes and models. In doing so, we recognize that the universe speaks not in human language, but in patterns, trajectories, and spectra. And yet, we are able to understand. This is the marvel, that beings born of dust on a small planet can read the dust of another system and find meaning. Atlas is not conscious, not deliberate, yet it communicates. It tells us of origins, of exile, of journeys through darkness. To say the universe is silent is to miss the speech written in its motions. Atlas is one of its words, uttered once, fleetingly, before drifting on. It is up to us to listen. To watch Atlas is to watch exile embodied. Once it belonged to another star, orbiting in its nursery of planets and dust. Then, by chance or collision, it was cast away, never to return. That story resonates deeply with us, for exile is one of humanity's oldest themes. We know the pain of leaving home, of wandering without return. In Atlas we see that exile is not only human, but cosmic. Stars themselves expel their children, systems send their fragments into the void. And yet, exile is not only loss. It is also journey, transformation, encounter. For had Atlas remained at home, it would never have been seen by us, never become part of our story. Its exile gives it meaning, just as human exile often shapes art, history, and resilience. The comet's arc across our sky is not tragedy, but testimony that even castaways can carry beauty into the eyes of strangers. Every great discovery spawns myth, whether we admit it or not. Ancient people saw comets as spears of gods, dragons in flight, omens of war. Today, we describe Atlas with mathematics, but the mythic thread still lingers. Some call it a messenger, some a ghost, some even a ship. Myth persists because it speaks to something beneath logic, our need for meaning. Atlas, in this sense, is not just a comet, it is a story seed. It will appear in poems, in speculative novels, in documentaries, in paintings. Children will imagine riding it across the stars. Philosophers will ask if its journey mirrors our own. Myth is how humanity internalizes science, how we fold cold data into warm narrative. The comet will fade, but the myths will persist, weaving Atlas into culture. Numbers fade from memory, stories endure. And so, Atlas becomes more than object. It becomes symbol. We must remind ourselves, the encounter is brief. Atlas is here for months, perhaps a year of observation, and then it is gone. That brevity shapes our experience. It heightens urgency, deepens awe, and forces us to savor. Just as a shooting star matters because it is fleeting, Atlas matters because its time is short. For humanity, encounters with interstellar visitors are like meetings with travelers on a mountain path, glances exchanged, questions half-asked, and then parting forever. This is not failure, it is the nature of the cosmos. The rarity of encounter gives weight to the act of noticing. If Atlas lingered, it might become ordinary. Because it departs, it remains extraordinary. That lesson extends beyond astronomy. It is a reminder to treasure the transient, to find meaning in moments, to let encounters change us even when they cannot stay. Soon, Atlas will slip into invisibility. Observatories will log their final spectra. Amateur astronomers will record their last blurred images. Papers will be published, archived, cited. And then, silence. The comet will continue its journey, but we will no longer follow. There is melancholy in this, but also wisdom. The art of letting go is as much part of science as discovery. We do not own the cosmos, we borrow glimpses. To let go gracefully is to acknowledge the vastness we cannot control. Atlas reminds us of this humility. We cannot hold it, cannot tether it, cannot slow its path. We can only learn what we can, while we can, and then release it. And in that release lies a beauty, the knowledge that we participated in its story without seeking to possess it. What remains when Atlas is gone? Not the comet itself, it will be a faint ember in the distance, lost to sight. What remains is memory, data, myth, and meaning. In our archives, terabytes of numbers, light curves, spectra. In our culture, stories of a visitor from another star. In our hearts, the awe of knowing that exile and journey connect not just humanity, but the universe itself. Atlas leaves behind no monuments, no traces on Earth. Yet it leaves us changed. It has expanded our vision, sharpened our instruments, and deepened our imagination. That is what remains, the invisible transformation of our species by a brief, passing point of light. Atlas may fade, but the questions it raises will linger. How many such visitors pass through our system each century? What diversity of sizes, shapes, and chemistries do they hold? Could some carry rare isotopes, or even compounds never before detected? Each unanswered question becomes a seed for future science. Young astronomers today, inspired by Atlas, may devote their careers to refining surveys, building instruments, and preparing intercept missions. Graduate students will mine its data, testing theories of dust dynamics, coma evolution, and interstellar ejection. A century from now, Atlas may be remembered less for its own details than for the discoveries it inspired, the telescopes it justified, the missions it provoked, the ideas it seeded. Like all pioneers, its greatest legacy may be what comes after. The story of humanity has always been about expansion, from caves to cities, from continents to planets, and now from planets to the cosmos. Atlas enters our narrative at precisely the right time, an era when we are beginning to see ourselves as cosmic beings. Just a century ago, interstellar comets were speculation. Today, they are observed fact. Tomorrow, they may be sampled. Atlas becomes a chapter in humanity's epic, the tale of a species that looked up, noticed, and recognized its kinship with wanderers. This chapter may seem small compared to wars or inventions, but in the long arc of history, it is monumental. It marks the moment when humanity began to treat the galaxy not as background scenery, but as an interactive stage, one where visitors arrive and we, in turn, prepare to one day depart. To watch Atlas is to confront mortality. The comet has lived for billions of years and will continue for billions more. We, by contrast, live only decades. Civilizations may last millennia, but even they are brief beside the comet's journey. This contrast can feel humbling, even crushing. Yet it also liberates. Our lives are short, but they intersect with eternity. To know that Atlas is passing during our lifetimes is to realize that meaning does not require permanence. Just as the comet is fleeting in our skies, so are we fleeting in the cosmos. Yet both matter. Both leave traces, comets in dust, humans in memory and culture. Mortality becomes not a weakness but a resonance, linking us to the transient nature of all things, from comets to civilizations to stars themselves. Perspective is perhaps Atlas's greatest gift. By existing, it forces us to step back from our daily concerns and remember the larger stage. Our struggles, our triumphs, our conflicts, all play out on a planet that is itself a speck, momentarily visited by another speck from another sun. This perspective does not diminish our lives, it enriches them. It shows us that we are part of a tapestry unimaginably vast, yet still capable of being glimpsed. Perspective reminds us to hold humility and wonder together. It teaches us that the universe does not revolve around us, yet it still offers us treasures like Atlas to study, to marvel at, and to fold into our shared human story. Legacy is not only what we leave behind, but what we take notice of. Atlas's legacy will be both. It leaves us with data and wonder, and we, in turn, give it memory. Long after the comet is gone, humanity will recall it as one of the first confirmed interstellar visitors. Its name, Atlas, will live on in archives, textbooks, and perhaps even monuments. And in doing so, we extend its story far beyond what physics alone would grant. In this way, Atlas gains immortality not by its own nature, but through our recognition. The universe is infinite, but recognition gives it intimacy. Atlas becomes not just a fragment drifting alone, but part of a legacy shared between stars and minds. Its journey continues outward, but a part of it remains forever here, within us. Every interstellar object is a promise. Atlas travels where we one day hope to follow. Humanity's greatest dream, the dream of becoming an interstellar species, finds in the comet a living example of the possible. If ice and dust can cross gulfs of light years, so can ships and people. Our challenge is technological, not theoretical. Atlas whispers, the path exists, physics allows it, the journey can be made. Already, concepts for fusion drives, solar sails, antimatter engines, and wormhole speculation emerge from laboratories and imaginations alike. Each is a bid to join the stream of wanderers. Atlas reminds us that interstellar travel is not the exception, but the rule. The universe itself conducts it constantly with debris. We need only learn to follow in its wake, transforming longing into trajectory. Despite its cosmic endurance, Atlas is fragile. A ball of dust and ice, porous, easily broken, vulnerable to the sun's heat. A close pass near a planet could shatter it, a collision could erase it instantly. Its survival depends on balance, cold enough to preserve, distant enough to endure, resilient enough to remain whole. That fragility mirrors us. Humanity, too, is fragile, dependent on atmosphere, climate, stability. Yet fragility does not mean weakness. It means delicacy, the kind that allows beauty. Atlas is fragile, yet it has crossed unimaginable distances. We are fragile, yet we have crossed oceans, space, and soon perhaps stars. Fragility is not the end of endurance, it is the texture of it. The comet teaches us that delicate things can travel far. If fragility defines its body, resilience defines its journey. Once ejected, Atlas endured cosmic rays, interstellar dust, and the tidal pull of countless stars. It continued onward, unbroken, until it found our sun. That resilience lies not in strength, but in persistence. Motion itself is the secret. Once set on its trajectory, nothing could stop it. In this sense, Atlas embodies resilience not as defiance, but as surrender to path. Humanity can learn from this. Resilience is not always force, sometimes it is the quiet commitment to continue. Like the comet, we may face storms, voids, and indifference, but motion itself carries us forward. The universe teaches, resilience is simply not stopping. When we speak of loneliness in the cosmos, we often mean life. Are we alone in intelligence, in consciousness? Atlas suggests another layer. We are not alone in matter. Our system is not closed, it exchanges with the galaxy. Fragments from other stars drift into our skies, and fragments of ours drift outward. There is a constant mingling of materials, a silent communion across vast distances. Even if life is rare, matter itself refuses isolation. Every interstellar comet is proof that the galaxy shares, trades, and mingles. We are not isolated pockets, but nodes in a network of exchange. Atlas is a handshake between stars, conducted not by minds, but by dust and ice. To realize this is to see that even in silence, the galaxy is connected. Motion unites us. Our Earth circles the Sun, our Sun circles the galaxy, and comets like Atlas cross paths in endless arcs. We are not static beings on a still planet, we are voyagers in perpetual orbit, companions in an eternal dance of trajectories. Atlas is a reminder that the cosmos is not empty space punctuated by isolated stars. It is a choreography, a ballet of bodies in ceaseless motion. To feel alone is to forget this truth. We are always surrounded by wanderers, always part of a greater movement. Atlas is not only a comet, it is proof that motion itself is a kind of kinship. In the galaxy's grand ballet, we are not spectators, we are dancers. Atlas is the third confirmed interstellar visitor. That fact alone implies a fourth is inevitable. Somewhere out there, another object already speeds toward us, its faint glow hidden in the star field. It may arrive in years, perhaps decades, but it will come. And when it does, we must be ready. Atlas has been our rehearsal, a reminder of the brevity of windows and the urgency of preparedness. Telescopes must grow sharper, surveys more vigilant, spacecraft more nimble. To greet the fourth is not merely to observe, it may be to intercept, to sample, to touch. The fourth interstellar object could be the one we study not just through light, but through matter itself. Humanity now knows the pattern. The sky has spoken 3 times. It will speak again. The question is not if, but when. The universe is an economy of matter, forever exchanging. Stars trade light, planets exchange fragments, galaxies collide and share stars. Atlas is part of this exchange, proof that no system hoards all it creates. Inevitability is written into its orbit, ejection, wandering, encounter, departure. It shows us that the Milky Way is less a collection of isolated stars and more a community, its members linked by drifting fragments. We are participants in this inevitability, too. Earth has already shed material into interstellar space, blasted away by asteroid impacts. Someday, our spacecraft will drift between stars like comets, carrying human fingerprints. Exchange is not an exception, it is the rule. Atlas is simply one of the first we've noticed, a messenger reminding us that the galaxy is a place of endless giving and receiving. A comet's orbit is mathematics, yet within the numbers lies poetry. Hyperbolic arcs are not closed, they are stories without return, verses that rhyme only once before moving on. Atlas's trajectory is a poem in motion, discovered, studied, and then released into infinity. To trace its path is to read a stanza written in dust and light. Astronomers calculate eccentricities and perihelion distances, but beyond the figures lies rhythm, symmetry, inevitability. Every orbit tells a story, every trajectory is a line of verse in the epic of the cosmos. Atlas reminds us that science and poetry are not opposites. They are mirrors. Science gives us the form, poetry gives us the meaning. Together, they allow us not only to measure the comet, but to feel it. There will come a night when Atlas is no longer visible. Its coma will shrink, its tail dissolve, its nucleus dim beyond detection. Astronomers will log the final observation, close the shutters, and turn their instruments elsewhere. For us, it will be gone. But for the comet itself, nothing ends. It continues outward, indifferent to our gaze, following the curve set for it eons ago. This fade is bittersweet. We mourn the loss of a presence, yet we know it was always temporary. The final fade is not failure, it is fulfillment. The comet came, was seen, was measured, and moved on. Its brief illumination was never meant to last. And that transience is what made it beautiful. As Atlas recedes into darkness, we are left with an irony. What feels like an ending is actually a beginning. It has opened a new chapter in astronomy, inspired new generations of scientists, sparked new ideas for missions, and reignited humanity's imagination. Its departure is not silence, but echo, an echo that will ripple through research, culture, and memory for decades. Endings in the cosmos are rarely final, they are transitions. Stars die and seed new stars. Comets fade and inspire new searches. Visitors leave and prepare us for the next. Atlas departs, but in its wake, it leaves beginnings everywhere, in technology, in philosophy, in art. The comet's true gift is not its presence, but its aftermath. For even as it fades, it ensures that we are looking higher, searching harder, and dreaming farther than before. Every time we study the universe, we end up seeing ourselves reflected in it. Atlas is no different. Its exile mirrors our migrations, its fragility mirrors our mortality, its resilience mirrors our will to endure. We do not only learn about the comet, we learn about ourselves. Astronomy has always been a mirror. When we discovered planets, we saw the possibility of other Earths. When we measured galaxies, we saw the enormity of our own smallness. With Atlas, we see the truth of wandering, that journeys define identity as much as destinations. Humanity, like the comet, is forever in motion, defined not only by where we began but by where we are going. In Atlas's path, we recognize the poetry of our own. For billions of years, comets like Atlas passed unnoticed through countless systems. But now, for the first time, one is seen, measured, and remembered by conscious beings. This moment is revolutionary. The universe is not only happening, it is being noticed. Awareness transforms raw motion into story, transforms physics into meaning. We are the part of the cosmos that looks back at itself. Without us, Atlas would be another silent wanderer. With us, it becomes a chapter, a message, a memory. Awareness gives the universe depth. And Atlas, in its brief glow, has been part of that awakening. It is no longer only matter, it is meaning, because we chose to notice. The comet will fade into darkness, but memory will preserve it. Long after it is gone, students will study its data, teachers will tell its story, writers will weave it into metaphor. In memory, Atlas becomes eternal. That is humanity's gift. We can hold what the universe releases. Matter drifts on, indifferent, but meaning lingers in us. Every equation written, every spectrum archived, every sentence spoken about Atlas ensures it remains alive in human thought. Eternity is not only a property of physics, it is also a property of memory. And in remembering, we grant Atlas a form of immortality it could never claim for itself. Atlas teaches us that we are not isolated, not central, not separate. We are part of a galaxy alive with motion, exchange, exile, and encounter. Our place is not to dominate, but to participate. We are wanderers too, carried on a small planet orbiting a modest star, drifting with a spiral arm around the Milky Way. In that sense, Atlas is not foreign, it is kin. To understand this is to shift perspective. The universe is not out there, it is with us. We are woven into its trajectories, as temporary and fleeting as the comet itself. Our place is humble, but it is also extraordinary, for among all wanderers, we are the ones who can notice, reflect, and give voice to what passes by. And so the comet departs. A faint spark dwindling into the infinite night, never to return, never to glance back. Yet in its wake, it leaves a whisper, soft but profound. The whisper says, the galaxy is larger than you imagined, yet more connected than you believed. The whisper says, exile and journey are not tragedy, but destiny. The whisper says, notice, remember, dream. For one day, humanity too will be the wanderer, passing through alien skies, carrying fragments of Earth into the stories of others. Atlas is gone, but its whisper remains, carried in data, in myth, in wonder. And as we stand beneath the same stars it now drifts beyond, we remember what it taught us. That the universe is not empty. That we are not alone. That even fleeting visitors can change us forever. From the moment of its discovery, Atlas became more than an object. It became a thread connecting observatories, cultures, generations, and imaginations. Scientists raced to log its spectra, artists painted it as a silver arc through alien skies, children whispered about visitors from other suns. These threads form a tapestry of connection that stretches beyond astronomy. The comet unites us, not because of what it is, but because of what it evokes. In its faint light, we saw the power of shared curiosity. No single nation or person can claim it. It belongs to all of us, a gift from the galaxy itself. Connection is its true orbit, weaving people together across borders, disciplines, and even time. When Atlas fades, the threads remain, reminding us that discovery is not solitary, but collective. Atlas forces us to rethink the galaxy not as a static canvas of stars, but as a living system in motion. Matter flows across its arms, stars shed fragments into the void, planets are born and destroyed, comets drift endlessly between suns. The Milky Way is alive, dynamic, restless. Atlas is one heartbeat of that system, one pulse of matter through the spiral arm. To recognize this is to move from seeing the galaxy as backdrop to seeing it as an organism of unimaginable scale, yet one that includes us. Every interstellar visitor is proof that the galaxy is not fixed, but alive with exchange. In this living system, we are not spectators. We are cells, pulses, participants. An atlas is our reminder of that shared life. Long after the instruments fall silent, what remains is wonder. Not the wonder of ignorance, but the wonder of knowing just enough to glimpse the vastness. Wonder is not childish, it is the beginning of wisdom. Atlas leaves us with questions unanswered, mysteries unresolved, but wonder intact. In fact, it strengthens wonder, proving that the universe can still surprise us, still offer the unexpected. Wonder is what will draw eyes to the next visitor, what will inspire new missions, what will keep humanity looking up. The echo of wonder is the comet's true legacy, for without wonder, data is cold. With wonder, data becomes story, and story becomes meaning. Atlas will fade, but the echo will resound in hearts long after the last spectrum is taken. Atlas reminds us of a promise we must keep, to keep looking, keep preparing, keep imagining. We are the first generation to notice such wanderers, but not the last. If we choose, future generations will be ready not only to observe, but to greet, to chase, perhaps even to capture. Humanity's promise is to carry forward the curiosity that made us look up in the first place. This promise binds us to the future, our children, and theirs after that. To fulfill it is to honor Atlas, to ensure that its fleeting passage was not merely recorded, but remembered as the moment when humanity resolved to step fully into the galactic story. That is the promise, that the next visitor will not pass unnoticed, and the next after that will not pass unchased. And so the lights dim, the telescopes turn away, and the sky resumes its quiet watch. 3i Atlas is gone, a wanderer on its endless path. Yet in its brief time with us, it transformed our vision. It showed us that exile can be beautiful, that fragility can endure, that motion itself is connection. It reminded us that the galaxy is not empty, but alive with exchange. It whispered that we, too, are wanderers, destined one day to cross the skies of others as this comet crossed ours. Its legacy is not in its dust, but in us, in the way it changed how we see, how we imagine, how we dream. This is the story of 3i Atlas. A story of exile, encounter, and departure. A story of science and myth, of numbers and meaning. A story of a visitor that came unbidden, stayed briefly, and left forever, but left us changed.